welcome to PDMA Corporation, home of the MC Emax, and our newly released PDMA I. We'd like to thank you for joining us as we continue along in our presentation series. Once again, we have the Vice President of Product Development, Mr. Noah Bethel.
Hello from sunny Tampa, Florida.
And I am the Vice President of Sales and Marketing, Todd Gunderson. And Noah, we're happy once again to have a case study in front of us, Overgreasing Synchronous Motor Bearings, why a baseline test can be so valuable.
So it wasn't the electrical fault?
Well, the motor doesn't start. So if the motor doesn't start, what's the first thing? It's got to be electrical. So Noah, let's get into our case study here. But before we start, what is a synchronous motor? What are they used for? How do they start up even?
Yeah, I love the picture. This is this motor has some age on it. Synchronous motors by name is magical.
Like us almost, right?
Almost like us, yes. Perfection.
Based on how you're sitting, I would say yes. Your back is killing you. The age has crept up on you.
All part of the experience. So back to synchronous motors. That by name, it kind of says what that does. The rotor turns in synchronous speed with the stator windings, magnetic
So there's
field.
no slip between the rotor or the stator.
Exactly.
And so you see, looks like there's slip rings there. Is that what they call those?
Yes, a good sign obvious sign that this is an externally excited synchronous motor. So we're pulling in a DC signal into those slip rings and running it through the field poles, which are wound on the rotor itself. Once that DC field is energized, that's when the rotor will actually turn at the same speed as the rotating magnetic field.
So it doesn't automatically start up in synchronicity, right? It starts up through almost like an induction motor you said, with amortisseur windings.
That is exactly
start
right.
Up the motor.
In fact, the resistor, the slip rings you see there and the brushes are literally shorted through a dissipation resistor to prevent high voltages from building up on those slip rings. So initially that circuit is completely out of the start process until the amortisseur windings, like you say, get it up to speed. Then the DC field is energized.
Okay, thank you for that explanation. Now, interesting. This actual asset had multiple problems with it, but it was over a couple of years span. So they started monitoring this in 2016. I think that's when they initially purchased this. And this is in a tire manufacturing facility. But we're really kind of stressing the importance of a baseline. And from this initial baseline, you can see in July that they actually started in May, but in July they ran a polarization index test, and it gave us the polarization index was a little lower, 1.2. So
in caution, yeah, I see that.
It's in caution, yeah. So we want to, but we always say the number, the actual, what's the ending number at this end of the 10-minute resistance ground check, and then what does the graph look like?
Absolutely. That profile is everything when it comes to PIs.
Yeah, so let's look here. This was the actual profile in July.
This is not good. Two things that you pointed out. Like, first of all, there's no polarizing effect. It's pretty much flatline the whole way, which is suspect of surface leakage. And then the amplitude, very low.
Yeah, so the ending amplitude was 19 megohms. Now, when I questioned the technician, he was unsure. All his notes said was 2 days later there was a new motor there. Now, whether that meant this went out for a cleaning or potentially getting a new motor put in place. But if you had not seen the initial baseline of that asset with a 3.95 polarization index number, maybe you don't touch this.
Right. It would come up in conversation. And one of the things that is sort of a dominant factor here, although that if this was the baseline test, we might say, hey, has it always been this way? Should we continue it? But the amplitude of 19 meg, as you pointed out, it's below the IEEE acceptable minimum. So some kind of
action. For a 2300 volt motor.
Absolutely, yeah. 100 meg minimum is what this should be. And for that, we should be taking some kind of action on this.
Okay. And they did. They did take action. And as a result of that action, 3 days later, you can see a massive difference in that polarization index test.
Right. Now we've pushed the polarization is now present. You can actually see the charging of the insulation, which means that surface leakage is no longer the dominant factor. And look at the amplitude. What are we up to there? 3, 4, 5,000 meg. It's so much better than it was.
0.2 gigohms to 5.6 gigohms. That's a huge, substantial
It's a lot.
increase in
Something
resistance.
definitely changed.
Something did change. Now, let's get to our second problem with the same asset. So we had the initial problem. Now this new motor in July of 2016, we take a basic standard test on the field of the synchronous field. And we get our measured megohms, 3.4 gigohms corrected to 2 gigohms, 28,500 picofarads, 2,570 millihenries. And then phase measure megohms, the phase 1 to 2, and then corrected.
Yeah, physical field resistance.
Field
basically.
resistance
yeah.
is
yeah.
what we're looking at there. Now I'm going to draw your attention to the 20th of November, 3 years later, and you'll see it's the same numbers, 2,540 millihenries. But the next day, it went to 116 millihenries. Can you tell us what happened there?
When we see stuff like this, I mean, that is such a huge number change. We almost wonder if they're checking the same motor. You know, are they literally testing a motor that's not the same? It's
And a lot
such
of the
drastic
data
drop.
still looks the same, right? There hasn't been a big change. We don't see any highlighted red or yellow, but only in that change from baseline in the millihenries, phase 1 to 2, F1 to F2.
Absolutely. And, you know, what's interesting is you know, if you look at the phase 1 to 2 measured resistance, right, that's the field resistance. And the baseline was in red, which is basically indicative of the nameplate resistance needs to be looked at and modified for temperature correction. They probably need to temperature correct that. It should not be red. That's a baseline that should be considered normal. And the values in that November reading, just like you said, did not stray very much. But the inductance down to 116, it appears, keep in mind, we're sending a signal into the slip ring through the field poles and back. With 2,500 millihenries dropping to 100, it almost looks like we are no longer even looking at the field poles, like they're gone.
Like we've lost 90% of the turns almost.
Absolutely. Like literally they've either burned them all up or they're bypassing them somehow.
Okay, so come to find out, because they get the call and they say, wait a second, I just tested this yesterday. It was perfectly fine. This motor won't start up. And then he went there and he found that there was essential. Well, before that, let's talk about the polarization index test. Once again, nothing going on here, nothing to see here. Very high levels of resistance to ground. So nothing's shorting to ground. So nothing's crossed over and gone to ground. But they found out that there was grease, overgreasing of the bearings, and then with the fans and everything blowing it shorted out the brush rigging that we saw in the initial picture of the Synchronous, that slip rings.
That's a big deal. That's why it's an overgreasing event. You know what's interesting is you can imagine the conversation. Hey, this motor just tripped. Well, I just tested it yesterday. It should be fine. Well, you better test it again. I think you missed something. No, he didn't miss anything at all, but someone fouled it up and
someone was right behind him
grease.
with a grease gun. And as soon as he tested it, they went to town on the asset.
I think they might have blown a seal on that bearing and got a little grease in on the slip rings.
That's quite possible. And then I think they had sleeve bearings, and then there's oil on the sleeve bearings, or is that
once they very likely a motor this size could have sleeve bearings or some type of oil bath bearing. But either way, the fact that you talk about grease, it's probably a regular ball bearing. They just blew the seal out and filled it with grease.
And now would that short the brushes? Because you have to have some. Is it not? Are the brushes not touching the slip ring, or what? What do you think would happen there?
My thought is everything was connected, right? And that basically the path that the grease took once it entered the environment of the motor frame itself, or the slip ring frame, if you'd look at it that way, effectively just contaminated right across the slip rings. We had a situation on the road once. We were in Canada. A brand new motor was delivered, a synchronous motor, and we just ran a simple test on the it was completely grounded, and we could hear it popping as we were doing the resistance to ground test. Ended up when they sealed the rotor circuit, with varnish, they ended up having carbon traces between the slip rings. It was the same effect. Lost all inductance of the field poles, and it was grounded. So I think that what we're dealing with here is just a full-out grease contamination where the overgreasing landed on or near the slip rings, shorting out the brushes, basically.
And they found a spare brush rigging set. They put that on the actual Synchronous asset. And now we're back in the normal range again, 26, 30 millihenries, 25, roughly 28, 20. back to the normal range.
Exactly,
So
right
you're-
where we should be. I
right-
still want them
right
to
where
look
we're
into that
back.
resistance measurement so they can normalize that, because 7.5, phase resistance just changes with temperature from 32 degrees down to 28 degrees. They just need to verify that value and turn that to a normal green reading.
Yeah. So why every asset needs a baseline test? I mean, this is kind of a really good, I would say it emphasizes why it's necessary. Always make sure to do a baseline test, for every motor in your inventory, especially the critical ones.
So important. It's kind of like, if you don't know where you came from, you don't know where you're at.
Yeah.
And so it's true in a motor. With the
In this
baseline,
case
it's
here,
so
they
critical.
may have just said this motor's failed. We need to send it out.
What an expensive endeavor.
That would have been an expensive problem if you didn't know that. At least they were on a pretty consistent testing regiment for the asset, but they knew the
Hats
baseline
off to them for that. Yeah.
Right, exactly.
Yeah.
But had you just gone on a one-time check, hey, the motor doesn't start. Well, you may have said, well, it's you've blown a
Field
stall-
pole.
Field
We
pole.
lost all the field poles. Don't know why. Just replace the motor.
You've lost 90% of the field poles.
Yeah.
Guess
Yeah.
what? It's not going to turn.
And you can only hope when it got to the shop and they have troubleshot it, they're like, all you need to do is replace the brush rigging that's
Yeah.
contaminated and up and running.
Yeah, so using your senses, obviously visually you would have seen the grease on there, but you were just there the day before and there was no issues with this asset. So we try to fix those problems before they become catastrophic, and quite honestly, catastrophic is expensive.
It's very
Usually expensive. So that was the end of that case study. We don't really have dollar figures for you because it was a relatively quick fix. We always like to thank you for your continued support of our case studies that we provide to you, bring to you. If you have a specific case study that you'd like to share with us, by all means, let us know. You can contact us at pdma@pdma.com or give us a phone call at 813-621-6463. Noah, until the next one, you stay safe. Get that back better.
It will. I'm working on it. I'm working on it every day.
Core exercises, that's what they tell you. And as well, you guys be safe out there, and we'll talk to you real soon. Thank you.